Hello, and welcome to today's lesson where we're going to look at more proportions, similarity, and congruence. We're going to be working with very specific parts of triangles in this lesson. Okay, so by the end of the lesson, you'll be able to solve problems using the relationships between corresponding parts of similar triangles. In doing this, we're going to be able to solve problems using the ratio of parts into which an angle bisector of a triangle divides the angles into the opposite sides. So now, when we look at triangles, okay, we can look at these triangle pairs that we have here. We can test for similarity. So when we're looking at the two triangles here, I'm going to set up the ratio 3/4. So left side over right side, make sure that it equals 9/12. And I'm just looking at the triangles themselves overall. So 3/4, 9/12, we cross multiply and we get 36 equals 36. Now we could also test with the 6 and 18 to make sure that these triangles are side, side, side similar. But now using that first ratio, okay, we're well on our way to proving that these triangles are similar. So what we want to look at is, what do we know about these angle bisectors? Okay, so in this case, these two lines through the middle are cutting these into equal angles. Now we can kind of tell that the triangles themselves are not similar, because when we're looking at triangle 1 versus triangle 2, even though we have the top angle the same, we can see that the bottom angles are different. I've got an obtuse angle here, and I've got 3 acute angles here, here, and here. Okay, and we don't know anything about those. But let's test a similarity statement and see if that works. Okay, so now from the first triangle, I am going to work with 3/5 equals, so I went left side over bisector length, equals, and I'm going to go to the next triangle, left side over bisector length. Okay, and we're checking to see these pieces here. We cross multiply, and we can see that we've got 45 equals 45. Okay, so that's true. Now, if we move to the altitude, we're starting at the tip or vertex point of the triangle. We're dropping down at a 90-degree angle here. Okay, so we have a perpendicular line to the opposite side. And, once again, we can tell based on the 3 measurements, this is still a 3, 4, 6. This is a 9, 12, 18. We know that those are similar triangles. So when we're setting up our ratio, we've got our ratio of, now I'm going to talk about the altitude in this. Okay, 3/4 left side over altitude. Does that equal left side over altitude? We cross multiply, 36 equals 36. Okay, and then the last thing that we can do is look at the medians. Remember, the medians cut the triangle into 2 equal pieces. Okay, so now we've cut that into equal lengths. And then once again, looking at our proportions, 3/4.5 equals 9/13.5. And then we just got to do some quick calculator work here. 4.5 times 9 equals 40.5. 3 times 13.5 equals 40.5. Okay, so now what we found, and we've now proved what's called the proportional parts conjecture. if two triangles are similar, then the corresponding angle bisectors altitudes and medians are proportional to the corresponding sides. So when we look at these triangles, if I'm trying to solve for x, as long as I make sure that I use the corresponding parts, and you have to make sure that you're matching the triangles properly, okay, because here we've got cat is similar to dog, okay, so we need to make sure that if I'm using the length CA, I would have to use the length DO. There's nothing there, so I can't use that length. But now if I use the length AT, which is 24, I can match that up with OG from the other triangle. So if I'm trying to solve for x, I would have x over 24 equals 18 over 28. Okay, make sure that you're lining up the pieces properly. Okay, so in this case, angle bisectors have to be on top. Over base length for each. Okay, so I've got angle bisector over base length, and then this one comes from the DOG triangle. This one is coming from the CAT triangle, and then we just cross multiply and solve. So we end up with 28x equals 432. And then we divide both sides by 28. Okay, and some of these answers aren't going to work out perfect. This one doesn't. Okay, so make sure you use your rounding rule, 1 decimal place, 2 decimal places. I'm going to round to 2 decimal places here, and I end up with 15.43. Always check and make sure that your answer makes sense. Okay, if we look at this situation, okay, 28 and 18 need to be bigger lengths than 24 and x. So the fact that the x is 15, that makes sense in this situation. Okay, now, how about using angle bisectors in opposite sides? Okay, this is a important advantage. Now, notice the triangles that we're working with, triangle 1, triangle 2, are not similar triangles. Okay, this is a very special investigation. It's a conjecture about the angle bisector and the opposite side lengths. So the nice part we know is, since we know that the two angles are equal, what happens is the side and this base length, the side and the base length are proportional, because as that side stretches out further, the base length is going to get bigger. If the side is shorter, like our 6 centimeter side here, the base is going to be shorter because we're connecting those parts, and it's just not connecting from as far out. Okay, so if we look at this ratio, remember, always stay one side versus the other. Make sure you're being consistent when you're setting up your ratios. So 6 over 3.6, the side over the base length, equals the side of 12 over the base length. Now, some of you might have already looked and noticed here at the scale factor, okay, but we will go through and multiply. 6 times 7.2 equals 43.2. And 3.6 times 12 is also 43.2. Okay, so we know that we have this comparison ratio that works. So now this gets us into the angle bisector opposite side conjecture. A bisector of an angle in a triangle divides the opposite side into two segments whose lengths are in the same ratio as each other. Okay, so as the opposite side. Okay, so we can say as the opposite side or as each other in this situation. Okay, so if we're looking at trying to solve for this situation, okay, notice we have to look for the fact that we have the two equal angles for the angle bisector. So then we know that our ratio of left over top is going to equal the ratio of right over top. Okay, we want to stay consistent with that setup. So I use the top and the left, so then I have to use the top and the right to set up my proportion appropriately. So we've got 6 times x equals 8 times 5, which is 40. So 6x equals 40. Divide both sides by 6, and we get x equals, okay, 6.6 repeating. Okay, so now in this situation, think about your two answers. We can list our answers in two possible ways. We can turn it into the lowest possible fraction. Okay, math, fraction, enter, enter. Okay, and we can get a perfect answer of 20/3. Okay, or we can have the, close but not precise 2 decimal place rounded answer. Now, your best answer is always the exact answer. Okay, remember, math, fraction, fraction on a TI-83, TI-84 calculator gets you to that spot. Now, what we can do is we can ask you to use some of your previous knowledge. If you notice this triangle, we've got a 30, 90. So up top here, this has to be a 60 as well. So we've got a 30, 60, 90 triangle, and we are trying to find x. Okay, now, normally, we would need this length right here. Okay, we can find that length. It's the hypotenuse of a 30, 60, 90 triangle. So we have to remember our reference triangle, 1 square root of 3, 2 for your typical 30, 60, 90 triangle. So we know that the hypotenuse is twice the base length. So we can end up finding that value of 12 by using the ratios. If we want to find the hypotenuse over base 6 equals, and then we go to our reference triangle, 2 over base 1. Okay, short leg is on bottom, hypotenuse is on top, and then we can cross multiply and see that the hypotenuse equals 12. Okay, so that is review of our 30, 60, 90 triangle. And then once we have that piece, then we can set up and solve our relationship here because of the angle bisectors. So left side over bottom equals right side over bottom. Okay, so we set up our ratios, and then we can cross multiply to solve. 6x equals 24 square root of 3. Divide both sides by 6. Okay, remember when we divide here, we're only dividing the front value. So 24 divided by 6 is 4 square root of 3. All right, and that concludes our lesson for today, talking about similarity with different segments within a triangle, and then finishing up looking specifically at the angle bisector and the relationship that the angle bisector creates within a triangle. Thank you and have a good day.